Thank you so much for that great introduction. We're so excited to be here today. And we've had a chance to watch some of the talks. It's so inspiring to see how much WIDS has grown since I was a student. It's incredible. And we'll start out by introducing ourselves. And we're really excited to share something that we've been building that touches on multiple arenas of data science.
Thank you. Thank you again for having us. We'll be speaking today on bringing motion diffusion models to immersive entertainment. And we'll start with an introduction of who are we. My name is Jhanvi. I'm the CEO. My background, I did my BA and MBA at Stanford. In between, I did go to film school and work at YouTube before starting the company with my sister. And I'll have Ketaki introduce herself.
And I was pretty much at Stanford for 8 years. I did my BA, MA, and PhD here at the Virtual Human Interaction Lab. My research is more on the technical side of virtual and augmented reality. I also did some perception research at MetaQuest VR and Google X on the Glass team, and then brought all of that work to Krikey, where I now manage all things engineering, product, and design.
And we'd love for you to connect with us. So these are our LinkedIn QR codes, so please find us after as well. We'd love to talk to each of you. So what is Krikey? So we are a company that builds AI tools. The tool we're going to be presenting to you today is an AI animation tool. Supplementary to that, we also have custom 3D avatar toolkits, augmented reality mobile app toolkits. And the idea behind all of these is to empower creators and developers to create content faster, integrate these AI tools into their creative production pipeline, and create high-quality content, even if they don't know how to code. Our AI to AR pipeline is pretty unique, and we're very excited to present it to you today. And you can, of course, check us out at krikey.ai. That's KRIKEY.ai. So how does it work for a customer? We'll start on the business side to understand what is the tool, why is it important? So what is the tool? You can go to krikey.ai, and all you have to do is enter a simple text prompt. Today, we only do humanoid avatars, so it'll be a simple human motion text, walk, run, jump. We do zombie walk, moonwalk. We do a couple other types of prompts as well. You can generate a 3D avatar animation in minutes. Today, this process takes 5 to 10 business days. With our AI animation tool, it can take 5 minutes. Does this mean that the artist is no longer a part of the process? Absolutely not. I went to film school, and it would break my heart if we did that. So the way we see our tool is a supplement to the artist. We can build, with an AI animation tool, 80% of the human avatar's motion. So this is basic full body motion. But the emotion, the personality of the character, has to still come from an artist. How do we make a character happy or sad? What are the nuances of the facial or the hand expression? Those elements would still come from an artist. So we want to pair AI animation with artistry to generate the next generation of animation and creativity. Once you've generated your animation, you can export directly to social media to share your video. You can export your video to another video editing software tool to make it fancier. And then you can also export an FBX or a rig file, which is the inner skeleton of the character. So if you've created a 3D model of a character elsewhere and you want to just bring the animation into that character, you can do that as well in any 3D game engine of choice. And so what is motion diffusion? You've probably heard a lot about LLM models. So these are text-to-text, like ChatGPT, text-to-image, like Stability AI. There's also a lot of AI text-to-3D model companies on the market today. Ours is motion-based. So our AI model is built off of motion, so animation, video, data sets. And Ketaki will be speaking more about that in a few minutes. And what are some of the use cases? So we've broadly categorized these into 6 verticals where we believe AI animation can have a direct impact. The most obvious being, of course, gaming and film. Bringing the time down for animation generation from 10 days to 5 minutes is huge, and it can directly impact creative production timelines in gaming and film. There's a lot of learning companies, like ed tech companies, that use animation for tutorials, for education modules, and this is another place where we believe this type of AI tool could have a significant impact. There's also lots of metaverse companies. So these are immersive technology companies, so ones that build XR, AR, and VR experiences. And so using our AI animation tool, they can quickly prototype and drop in animated human characters to their experiences. Social media companies as well. There are a lot of places where you can generate a custom 3D avatar, but you can't animate them yourselves anywhere today. With our AI animation tool, you can actually not only create your custom avatar, but also animate it yourself. And then, of course, cloud companies, because to run any AI model takes a lot of GPU, and so there's certainly collaboration opportunities there as well. Some quick examples we'll run through. These are from our tool. So this was generated with the prompt jumping jacks, and this you can change the speed of the animation, you can change the camera angle, you can customize the avatar. We do offer a generic or a humanoid rig, and you can switch between the two. We also have the ability to recognize the right and left side of the body. So you can see with this prompt, we've indicated for the character to move the left hand. You can keep or drop the shadow. You can change the background environment. And then, of course, you can export this into your own project and do what you would like with it, with your creativity. And you are welcome to try this tool today at our website, Krikey.ai. It is available only on desktop at the moment. We do hope to add a mobile version of it soon. And I'll pass it over to Ketaki to talk more about how this works technically.
Yeah, thanks so much, Jhanvi, for sharing a little bit more about the end user experience and the business side of the tool. Now, of course, how did we build this and what were some of the challenges we faced? So first of all, to train a model like this and to build one, we need to go out and find a lot of data, right? So ultimately, the model is outputting predictions based on the data points that we've trained it against, and there's two different types of data. Because this is a text to animation model, we have to find motion data. So this could be motion capture data from people wearing mocap suits. It could be video data, so there's two options there. And then we actually have to text annotate all of this information with reasonable prompts. So for example, the video here, a reasonable annotation would be a person does a handstand. An unreasonable annotation might be a person stands up, right? So that's sort of correct, but it's not really what we're looking for, because later when customers are entering text prompts into the model, they're unlikely to get the right output if they put in something like handstand. So once we've sourced the data, and we'll talk more about exactly how hard is it to get motion data, but once we've sourced it, we then have to convert those data points into a format that we can actually use for training the model. And this is actually a multi-step process, especially when we're trying to train against video data. Videos are, of course, a 2D media format, right? So when we're watching people move in a video, we don't actually know the 3D position, rotation, and orientation of those people. We simply know that they're moving. So even though we have videos, we can't just immediately input them and train the model against them. We have to estimate the location of humans and their motion vectors in a given video frame, and then those are the data points that we'll train the model against. This is an algorithm called pose estimation. There's many ways to do this. The way we did it is shown in the GIF here. So what we're doing for all of these videos is we're estimating the position of all the joints in the human body, and we actually map those to a generic 3D avatar. So you can see in this video, the avatar is doing a handstand just like the original person in the video. Once we have the pose estimation data and the text annotations, we can actually begin to train the model. Now, once we have the model prediction outputs, this is essentially a Python file with 54 motion vectors, each with an X, Y, and Z value. Again, this is a flat file format, right? So we have to take these 2D motion vectors, convert them to 3D, and then map them once again onto humanoid rig joints so we can get the end output of the videos you saw earlier of a 3D character that is fully animated. And so there's a lot of challenges with finding videos that are actually going to be good quality to train the data on. So there's one example here at right. Obviously does not look as good as the handstand video that we saw before. And probably a surprise to nobody here who's ever tried to do any type of research, most data points are going to be like this, right? So training data doesn't come perfect. We have to find a good way to filter it. And so a few of the challenges here. So first of all, long clips. So if a video is 30 or 40 seconds long, that's probably too long to use for a training data point, right? So much can happen in a 30-second time span. We're really looking to kind of cut videos down to 3 to 5 seconds so we can really focus in on getting one action per data point. The second thing is number of humans. So again, that previous video that we looked at, that was a great video because it was one person doing a handstand against a totally clean background. This C-SPAN video, a lot more difficult, right? So there's multiple people in the camera. The camera angles are also changing. So we're cutting between different views of the room. the pose estimation algorithm is not perfect. So it doesn't understand what's happening when there's quick cuts, too many humans layered on top of each other in a frame. And of course, this video is also torso up, so we're missing the bottom half of the motion. So if we were to take the outputs of pose estimation, you can see right away that there's a lot of jitter in the motion vectors that are being estimated. This type of training data will lead to inaccurate model predictions and therefore a lower quality product at the end. And so again, just to reiterate, we've got to find a way to build a training pipeline that's going to filter out good videos and poor videos. Good videos have one human, a clear physical action, and just a singular camera angle. And then poor videos often have multiple humans, camera angles, and they're not full body. And again, to be clear, a starting video of 30 seconds, it could contain good clips and bad clips, right? So there's a lot of gray area here where we might get a lot of training data, and then we have to find a way to cut it up and sort through it to make sure that it's actually going to be usable for our purposes. And then once we've actually found our training data, we then have to start to annotate it. So I'll actually first just briefly touch on this video at right. So this is actually a real clip of a training video that we've ended up annotating, and you'll notice that it actually looks different than the videos we saw before. So the reason is we've actually taken a long clip of people playing volleyball, and we had to cut the clip so that, there's 12 people, right, on the volleyball court. We had to crop the video so that every person doing an action became their own video clip. The reason we had to do this was that if we took the raw volleyball video of 12 people and tried to train the model against that, we're going to end up with very inaccurate motion predictions because there's too many people in the same camera frame. Now, with the video we have at right, there's just one person, they're kicking a ball, it's very clear what the action is, and there's no one else in that training data point. So the next step would now be to annotate this video. We do have to use a manual process to label videos. The reason for this is that if you try to automate it, you will often get very low intercoder reliability. Now, what is intercoder reliability? It's basically us checking, okay, this video has 3 different labels. How similar are these labels? And then how accurate do we think these labels are? So again, thinking about this video, one coder might say a person kicks a ball. Okay, that's pretty good. Someone else might say a person plays volleyball. That's less good, right? Because it's not really clear that the person's playing volleyball from this clip. We would only know that if we see the broader context of the video, and that's not really relevant to the current data point. So this is another challenge that we've excited to say we've overcome with a long process, but it's important to get this right so that the end quality of the product is high. And then again, annotation examples. So strong annotation here would be a person jumps up and down, moving both arms and legs. A poor annotation would be simply jumping. While it's true that the person here is jumping, that doesn't really provide quite enough data for us to train the model effectively. And then this leads me to the next question, which is where are all the open source video data sets? So this is a surprisingly difficult challenge for anyone who's trying to train any AI model today. There's not a lot of open source video data sets to begin with. The ones that are available are often extremely specific, so they're all about cooking because there was a research paper about actions of cooking in the kitchen. There's specific sports data sets, but there's not really one big open source data set that contains a really wide range of humanoid motion. So the first challenge is the content that's out there is incomplete. The second challenge is private motion data sets. So of course there's a lot of videos out there that would be great for our purposes, but they are private, so we have to go and get copyright and licensing rights. The third option, of course, is to create our own data set, but of course that's very costly and it takes quite a lot of time as well. Oops. Sorry, there we go. So the next steps for us are to continue to try to build out a big motion data set, a combination of motion capture data and video data, which we eventually hope to share with the broader research community. The reason for this is that we know that more video data is needed. We know that better annotations are needed. We've been able to make use of what's out there so far to train our model, but we hope that more people can build on our work, and we know that there's a lot more to do. And eventually we hope to expand our current model to non-human characters as well, for example, dogs or dragons. And lastly, we just want to say thanks so much for having us here today. We're huge fans of WIDS, and please come see us afterwards at the reception. We'd love to meet all of you, and thank you so much.
Wonderful.
Thank you.